Session 5, Agricultural Plastic Recycling, General Session. So Kevin's being a little loud and boisterous. That's par for the course, but we love the enthusiasm. We love it, especially at the end of this conference. Before we begin, I just want to follow suit with some of the other moderators and just acknowledge Gene Jones and his team for organizing and executing such a wonderful conference. And then all of the speakers, like just the professionalism, the level of information, just thank you. And we're going to have 3 final speakers that are going to be presenting on their work with regards to the topic of agricultural plastics. Our first one is my friend and colleague, Dr. Karl Englund. He's an associate research professor at Washington State University, and the title of his presentation is Mulch Feedstock Preparation and Initial Properties. So let's all welcome Karl.
Thanks, Lisa. Thanks, Gene, all the team. You guys did a great job. You guys hear me all right? I'm a little bit taller than Lisa, so I have to move this up. And Lisa said thanks to all speakers, but she said that before I got up here, so hopefully I'll keep up on that. So I changed the title because I thought the title was really boring and stupid, but, okay. So I'm Karl Englund. I'm at Washington State University. I'm working on a project with Lisa and Quinn and Kevin and a bunch of other people that you saw in here kind of giving presentations. But the person that did all the work in this is actually my grad student, Fumaleo, and she is not here right now, but I want to make sure she gets recognized in that. And then my other colleague, Dr. Huili, in this case, too. So I'm going to give you a basic overview. Hopefully, am I too loud on this? Or? Okay, good. Basic project overview, just real simple kind of thing. As you saw with a lot of the work that, if you were here for the workshop thing, we do quite a bit of work on this project related to biodegradable mulches. I'm going to focus this presentation on the low density polyethylene or synthetic mulches, as you can see, and look at a couple of different recycling methods. You already saw a couple of them this morning with Dr. Bob and Kevin over here talking about the gasification pyrolysis, basically burning under anaerobic conditions. But we'll also hear from Quinn Zhang, who's coming up next on the asphalt side. And then here at WSU, we're going to do quite a bit on some of the composites. But I don't have any data yet on the composites that we're going to make yet. But I wanted to kind of get a little bit more into kind of looking at the 800-pound gorilla that's in the room that everybody knows it's about is all this soil. I mean, when you get right down to it, we don't use these plastics. Trex doesn't want to take it. Nobody wants to take it because it's got too much stuff on it. And so I kind of want to start taking a look at some of the work that we've done, some of the initial results that we have already seen in some of our project. And like I said, this is an ongoing project, so we're right in the middle of it. So we'll look at some of the next steps that we're going to go through. Let's get started on here. So the project is a USDA SCRI, Specialty Crop Research Initiative, right? Okay. And it's a very diverse group of folks. Lisa is in plant, she deals with plants. I don't even know what she does kind of thing, but it's a very diverse group. We do a lot with the actual strawberry mulches that we're looking at here. Yield influences, anything that has effect on that kind of stuff. Like we saw on Wednesday, looking at the bio-based mulches and some of the work that we're doing in that regard. And then a lot of this is really influence on soil chemistry and stuff that I really don't know a whole lot about, so I'm not going to talk about that. This talk is going to be more focused on what do you do with that mulch film. We've all kind of looked at the different technologies that are out there, and I'm not enforcing or saying which one's the best. I'm just looking at it, get the dirt and the soil off of it, and this is what you can do with it kind of thing. And so we have 4 different test sites that I'll get into that I'll show you. And then we also have some commercial film that Gene Jones gave us from Swix that has been great that we can work with. This is how we've kind of taken it off, the manual labor kind of thing. So everything that we look at when we look at removal of these mulch films, it's going to be all through manual labor. And so our sites are Mount Vernon, Washington, where Lisa's at, and then if you saw Sam Morton in Nebraska, that's through the other site, and then down in Florida, I don't even know how to say that name, but it's down in Florida. And then we also have a moss landing up here in California. You're not going to see any moss landing data because of the pretty bad growing season and all the issues that we had with wind and rain, and we actually didn't get any harvested mulches out of there that were reliable. And like I said, you know, this project is not about the cleaning technologies. I don't really want to look at that too much. I just want to look at what is on there, why it's on there, and how we can deal with it. So the location is really kind of key in this whole project, and how temp and UV affects the performance, the moisture content, the soil type that you're going to see in there. And then the fertilizers and then all the other sides that you use, the insecticides and herbicides, how are they going to affect the plastic and how are they going to affect its final properties? So, as I said, we have 3 different recycling pathways that we're going to look at. And the first one you saw with Bob and Kevin talking about the advanced thermal pyrolysis, however you want to look at it, kind of technology. And then, as I said, Quinn's going to give a talk here in a second on the asphalt side of it, and then WSU is going to start looking at the composite side, which is still in the making kind of right now. We really kind of looked at these recycling technologies based on a realistic approach. Low-density polyethylene, as you guys know, is the predominant, or linear low-density polyethylene is the predominant plastic that you're going to see in mulch films. And it's a great material for making packaging, but it's really hard to take a recycled material and turn it back into a blown film that LDPE is commonly in. And so finding the right type of second end use, the durable goods or the pyrolysis or the asphalt, is not the easiest thing to do when you're dealing with these kind of materials. And so you just have to look at, there is a lot of effort that goes into making an LDPE in a virgin form to blow mold that. It's cheap, but there's a lot of real tight processing window in there. When you start adding all these contaminants and you put all this different material in there, you get these recycled, you might get some gel from the crosslink with the UV. All that's going to affect your blow capacity and how this material is turned into films. And so finding other applications besides it going back into a film, it doesn't mean you can't put it back into a film, but not putting it back into a film is probably the best way to do it if you want to make it economically viable. So our feedstock process, or how we take this material, we get it as is, we get it in bags or boxes or however it comes in. We'll shred it down a little bit to kind of get it into a form that we can then feed it. And then we put it into a pelletizer. And up here you can kind of see, oh, there it goes. Feedstock form, we got a little pellet mill right there, it's Funimileo, got feeding in. You got a little single disc ring pellet mill that we could put the material in and get it densified a bit so that we can start dealing with it. It makes it a little bit easier. Now, as we go through all that, we want to start taking a look at what's the quality, what's the moisture content, what's the soil level, the ash content, those kind of things. So as we go through this feedstock preparation process, we want to see what we're doing to the plastic as we manipulate it and turn it into something that's useful. And so as you can see right down there, the PS is just the polymer to soil content ratio. I'll just look at just the soil content, or tramp load if you want to look at Kevin's terminology. And then the ash content, where you actually burn all the plastic off and you look at the residuals from there, gives you more of a true sense of the inorganics that are in there. And then moisture content, of course, is always a big role that we see in here. And as I said, these materials that once we get done pelletizing them and breaking them down, we send them to Quinn for his work, send them to Kevin for his work, and then we'll do a bunch of work at WSU. So we can start taking a look at a semi-realistic approach of how this material is going to get flow into its secondary application. So we kind of have a commercial scale product into. When we do this work in the fields and we get these mulch films, I was really, really shocked how thin these things are and how much material we really don't get when we start looking at a research sense here. So we were like, let's get some more material, so we got more material to play with. And so we got some, and Gene was great. He's not here right now, but I'm sure he's listening in. He sent us a couple bales, so we got roughly 2,000 pounds maybe, depending upon moisture content and soil contents on there. And so he sent it to us. It's the film material, as you can see right here. Wow, that's weird. You can see that's, oh, there it goes. That's the film that we're getting. It has since it's from Florida, it has the aluminum layer on there, and it's also white, so it doesn't build up too much heat in there. So we've been taking that. We have a larger, the next picture is Fumi working on our larger pellet mill. This is anywhere from 1,000 to 2,000 pounds an hour kind of mill that we have. It's a double roller ring mill by CPM that we use, and you make a product that's similar to what you see out there in the pellet industry. It's a little bit bigger just because of the way we had to process it. But I always like to tell people you pelletize it, you compress it down, and to get that compression ratio so you're not shipping air, you're not dealing with anything, and you get it into a form that feeds a lot better into your secondary process. And that's key. You can't take a bale of plastic, even in a wrapped or compressed bale, and expect it to feed into things very well. But you can definitely take a pellet and use that to feed into a lot of different things. And that's why we agglomerate, and that's why we do these things to make it feed a little bit better. And you can see we get about a 9-to-1 compression ratio on there. We're at about 40% or 40 pounds per cubic foot. Now granted, that may not be all plastic, okay? And this is a Swix material, and I'll get into that in a second here. So what we want to do is I showed you the metrics that we're going to look at here. We want to get a moisture content feel of the material. We also want to get a soil contaminants understanding of where it is. And then finally, of that material that's washed and cleaned relatively well, we'll get an ash content. And we use the standard methods for ash content based upon the standards. With soil contaminants, we talked to Gene about how he was doing it, talked to other people. I'd really like to kind of uniform this a little bit so we're all talking the same language whenever we say soil contaminants. But we basically we washed the specimens 4 times. And the first time you kind of put it in water, you agitate it a little bit, take it out, and then you do it again. You do that 4 times until we get to a point. And the reason we picked 4 is because we played around with it. We looked at a lot of different things until we got to the point where the waste or the water that we were agitating it in came out clear. And so after 4 times, we got to that point. And so we felt pretty confident that we were at a point where we were getting most of it off that we could get off. We didn't want to start scrubbing it or put too hot of water in there because we want to keep the plastic still intact, and we want to see how the plastic is. And so when you look at it, then your effective plastic content would be then the total of the weight that you have minus your moisture content, your soil content, and your ash content. The other thing that we looked at is what these things look like on the surface. If you look at a mulch film right now, it looks pretty smooth. It's pretty nice and smooth. But when you actually do a microscopic evaluation of it, it's not very smooth. It actually has a micro embossing technique that they use. The good thing is that between the different sites we have, the Washington, Nebraska, and Florida, they're all pretty much the same, and so we're happy with that. The question is you can see that so we have a virgin on the one side here and then a recycled on the other side, and you can see that they're still intact. You can definitely see that you still have the bumps or the asperities that you see in there, kind of thing. And the question comes to it is it deteriorating with UV on there, or is that just still buildup? That's one of the things we need to kind of figure out. But you can definitely see that this is of the washed film, of the recycled film we got, and then it's the virgin film that we looked at there. And so a lot of this kind of comes into play is how well this soil will actually want to stick to the plastic. And that's what it really comes down to. The less plastic doesn't like to stick to anything. I mean, it's really hard to bond stuff to a plastic. And so we want to use that technique and be able to say, let's figure out a way to make this material get off of there quicker with it being cheap and economical. So moisture matters just like size matters in a lot of cases kind of thing. So if you look at this, when we looked at the Washington, when we were up in Mount Vernon collecting this material, it was pretty wet out. And when we harvested it, it was raining. I think it was raining, wasn't it raining, or it recently rained? It was typical Washington October weather kind of thing. And so we ended up getting a pretty high moisture content by the time it got back to our lab. We had about a 45% moisture content. When we got the material from Nebraska, it was about 28. And then, believe it or not, when we got the stuff from Florida, it was about a 1.7. I was just in Tampa the other week, and it was during Debbie, and I never thought Florida got that dry, but evidently it was pretty low at that time. And you can see, if you look at, so that's your moisture content there. And so what we'll do is we measured the moisture content as is, so when we first delivered it, first got it in, and then we do it after we shred it, because we'll shred it down and then we lay it out on the floor to kind of let it dry a little bit. And then we'll pelletize it. And so she started taking a look at the moisture contents throughout all those operations, and you can see after you just air dry it for a little bit, you get a pretty high reduction in your moisture content. So the next thing we did with that is you take that dried film there, and then you look at how much soil's on there. Or you can take a look at the as-is and get a soil content. And so with the Washington, where it's nice and wet and everything, we did see pretty high soil content levels, 87%, which is really high. Once we air dried it after shredding, got it down to 70%, but that's still quite a bit of material on there. If you look at the Florida site, we started out with 33% soil contaminants, and then we got down to about 12% when it's air dried. Same thing with the Swix material. Swix material came in, it was shredded for us because it was so much material, we wanted to have it shredded before we got it kind of thing. It came in at what Gene was basically saying, 70, 80%. We got about 73%, so our data lines up pretty well with what Gene is getting. But we just kind of did the second bale. In the second bale, I said, all right, guys, let's get a little bit lower contaminant level, because when we did the first run of the Swix material, we just took it right out of the bale. Just took it in and just made pellets out of it. So it had that high contaminant level. The second round, we said, let's roll it out. Let's take that bale, and we have enough space in our lab that we could just kind of lay it out on the ground, let it dry for 6-7 days, and then when we go to process it and turn it into a pellet, let's pick it up and just shake it a little bit, and not try to pick up all the dirt and the soil and everything that came out of the bale. Got it down to about 5.13% soil contaminant. That's just drying and just picking it up off the ground. That was pretty amazing in my mind, to get that kind of reduction just by drying it and letting it sit. But what I want you to kind of look at here before I leave this is that if you look at the Washington and the Swix material, they're about the same, let's call them the same contaminant level. And so we'll just take a look at that down the road here, and I want you guys to remember that one. So ash content, that's when you take the material that's been washed, that we've washed 4 times and all that kind of stuff, and then we get the actual content of the inorganics in there. So we just kind of run it at 600 degrees C for a couple hours, and then we end up getting what we classify as an ash content. And so if you look at the red bars there, that's a virgin mulch film. So that's the mulch film that's stayed in the box that we got, that was plated, that was going to be put out on the field, but it didn't. It just stayed in the box. It's never seen sunlight. It's never seen soil, and so that's your virgin mulch. And so you're about 0.5% of ash content, which is about normal because that's your pigments. They may use a little calcium carbonate in there to extend the resin out, but that's about normal. But you can still see, even after 4 washes, we still have some soil or contaminant load on there. And so we're up around 3%, maybe down to 2.1 with the Florida material. But I just want to let you know, it may look clean and your wastewater, your wash water may be clean out of there, but you're still always going to have a little bit of soil on there, depending upon how you look at it. And so that's something you need to take into consideration. The other thing is that if you look at the Swix material, I didn't put that on the graph, but that came up to about a 7.3, so it's quite a bit higher. And that's mainly because the aluminum that was on the surface of that, that was there. So, all right. So next thing I want to do is I want to look at how this material flows and how this material behaves when you heat it up and you process it into something else. And the way you look at polymers is through what we classify as rheometry. It just measures how things flow. And one of the ways that we do that is through parallel plate rheometry. So you put your sample in between here. I don't like this thing, but put your sample in between here, kind of thing like that. And you have these heated plates that are on the top and bottom. The bottom is a fixed plate. The top is a rotating plate. And so we basically cut our samples out. And basically what you do in this is you heat it up, and then you just kind of spin that plate, all right? And you just kind of measure the load that it takes to spin that. Okay. Now, when you want to use this, we're using it at 190 degrees C, so everything should be pretty melted and all that kind of stuff. We made our material out of the as-is material, so it's got a bunch of the contaminants in the soil in there, kind of thing like that. And we had a gap of about 0.75 millimeters. So if you look at this data, don't fall asleep on me yet. Okay, I know it's data, it's a curve, and it's busy. So if you look at this is like I said, it's the as-is material. So it's got a lot of load of materials in there and all that kind of stuff. So if you look at the 10 rads per second, that's 10 radians per second. So it's in a circle, so it's just radians is how you measure the displacement, how much you're moving. And so 10 rads per second is relatively slow. And so you're spinning it. And then your x-axis is your strength. So that's how far you're spinning it. So the 10 rads per second is going like this. 100 rads per second is going really fast, and you're looking at a more quickly high velocity speed there kind of thing. And this thing, right, what we're seeing with this is that once you do the higher rads per second to higher speed at a really high displacement, that's when you start to see things change. You start to see things go away from a linear viscosity, linear viscoelastic property into this nonlinear chaos that's going on. And you can see in this right here, this green dotted line is really getting out there. It's going crazy. Well, that's the Swix material, I think. Yeah, the Swix material right there. And then the yellow line that's down here, that is the Florida material. So both of the Florida materials are giving us this huge brittle behavior. But you got to remember we said the Washington material and the Swix material are about the same load? Well, you look at this and you see, well, here's Swix, it's way up here, it's getting brittle behavior as can be, and here's the Washington material. It's not doing as much, but it's the same contaminant load. And so it's telling us that there's something different just about the soil type that's going to affect this thing. And so what we want to do next, well, this is another parallel plate rheometry kind of thing that I'll go into, but it's also showing, this is angular frequency. It's also looking at this as a viscosity measurement here. So the higher the filler, the heavier the viscosity or the higher the viscosity is going to be. And you can see the Swix material, once again, is pretty high. The Washington material is a little bit lower, and the Nebraska material, which didn't have a whole lot in it, is down here where all the virgin lines are, and these are the recycled lines. That's just telling you that the higher filler content you got in there is going to affect the viscosity. And the Florida-based material is going to affect it even more. And so why do we see that? Well, we started looking into when Fumi would take the sample and get a soil content analysis, we get the soil that's on the film, right? Well, she said, let's start taking a look at this soil and see exactly what it is. And one of the things that really affects your viscosity and how these materials flow and how their properties behave is that size. And if you look at this data, you can see the green line. We only have this for the Swix, the Washington, and the Florida material. You can see the Florida material and the Swix material basically from the same area. They're huge particles. There's not a lot of big or not a lot of small stuff in there, whereas the Washington is a lot finer material. It's probably going to stick to the plastic a little more. It may have a little bit more clay in it, so that clay is going to give that natural hydraulic cement kind of behavior kind of thing. But if you look at the Swix material, it's big chunks of sand, which is what you're seeing in Florida. So even the site location is going to give you a different performance and a different attribute of what your film is going to give you. either in the final product or how you clean it. All those kind of things need to be taken into consideration. So the next steps, I probably went a little fast, but hey, no, it's worked out pretty good. Next steps, we're gonna stay tuned for a lot of the composite stuff. Funmi is really anxious to actually do something with this material and not just analyze it anymore. So we're gonna do quite a bit on the composites production. We're gonna do some extrusion work, and we're gonna do some flat pressed MDF fiber type products kind of thing. We're gonna do a lot more on the particle size effects. I think that that's a really big field that really needs to kind of be taken into consideration. Also looking at the chemical nature. You know, one of the things with when you add an insecticide or fertilizer and all, there is a vapor, there is an odor that the talks yesterday kind of talked about odor removal. Well, odor removal is also a biggie while you're processing it too, and the harm and potential hazards that could be on the people that are processing it. So we want to take a look at the different types of chemicals and how they might affect, and we did some initial work here on HPLC on some of the glufosinate, which I think is a family of fertilizers that are used commonly out there. We didn't see a whole lot, but we did see some on the pellet where we concentrated a little bit more, and so we're going to keep that on there. The UV capacity, UV has a tendency to really kind of mess up the plastic as far as cross-linking it and turning it into a gel or a harder unit in there. So we're going to take a look at that. And we really want to see how that affects then the final properties and also the processing performance. So with that being said, thanks for USDA and acknowledge all that kind of good stuff. And I changed up my background. Instead of a strawberry field, I put an actual mulch film kind of thing. So if you guys got any questions, we got a couple minutes for questions kind of thing, or we can save them till later. And thanks a lot for everybody for sticking around. I know it's kind of getting late in the show, so thanks.
For the samples in California, of course, we know the plastic is still on because it won't get removed until the end of this month. But what would you expect for California based sort of some of your preliminary results? Do you think it would be more like Washington?
I don't know soils real well, but I'm anticipating, you know, it being, I don't know. I really don't know. I'm really I'm hoping it's not as tacky as the clay-like soil that we're seeing in the Mount Vernon site. Maybe it'll be a little bit more like Nebraska or Florida, but that's the beauty of research, is just trying to figure it out and say, yeah, this is really cool. And so I think we're gonna tie that back into soil. A lot of the work that Marcus Fleury is doing on the soil chemistry and the soil work that we're looking at there, and how we can say, yeah, we have these kind of components in there, we're going to get more tack, we're going to get more stick going on with the plastic, and that's going to be a little bit harder to take care of and all that kind of stuff. So.
And then my follow-up question is, not only is there a difference in soil type, but obviously just in the amount of time from which the plastic was out in California. It was laid out in October, and it's going to be removed now in August. So the UV exposure there is significantly longer than in some of the other sites, so I'm wondering that might also have an impact.
Yeah. And you know, so most of these plastics are going to have some type of UV stabilization, whether it be an additive that they put in there to scavenge the UV free radicals that occur, or a blocking agent, like the aluminum that came out of the Swix material kind of thing. And so I think it'll be really interesting to see if those are actually working, for one thing, and then how they're going to affect the polymer rheology and how this material flows, because then that basically, when you start cross-linking it, making like a PEX tubing for your bathroom or whatever kind of thing, you start to then make things that aren't going to melt and go back into a flowable solution that's going to be these particles, and so it basically becomes like the soil at that time. So how much of that is going to affect it? It could be quite a bit, because it is a pretty thin film, and a lot of it's being exposed to UV, so it'll be, I'm looking forward to seeing what we get. So
Yeah,
thanks.
exactly. Thank you.
Leoniel with the Ag Container Recycling Council. So I had a question about the test that you ran with the contaminants. I was wondering what active ingredients you tested for, like the number of active ingredients, Did you test for like the most used active ingredients, or all of them that are used on the market?
You mean as far as for the
Or
pesticides?
like pesticides
Yeah,
and-
so that's been a really big question, because we could scan it through and do a bunch of different HPLC tests, and then it would be just outrageous kind of thing. So we're trying to figure out what is used the most, and this is why we like to
That's
get a history of everything that's put in there. The same thing with you guys, looking
Yeah.
at the chemicals that are in there, and what is used the most. And so that's when we looked at some of the stuff, when we first did this HPLC, we looked at, this is the Mount Vernon stuff, and so we kind of had a little bit more control over it. Well, we knew kind of a little bit more because it's part of our group right there that could give us that information pretty quickly. And we kind of targeted a couple different items.
Oh, great.
But if we have something specific that like, oh yeah, this is really starting to cause some issues, or this smells like this, or whatever kind of thing, then we can start targeting that analysis. Doing a broad sweep analysis of a huge amount of, the amount of pesticides and fumigants and everything is amazing. How much is out there and how many different families of chemical family classes are in there. It's tough to do all of it. So we want to target the ones that we think are going to have the biggest impact. So.
Are you able to say what lab you guys have been working with to?
We worked with a lab, right, and so I'm in Pullman, Washington, and there's a water chemical lab and tech in Moscow, Idaho, which is part of the university system there that did it for us kind of thing. And they do this stuff all the time, so.
Oh, great. Great.
Yeah.
Thank
So
you.
If you want information on it, just send me an email and get you
Yeah.
hooked up, so.
That'd be great.
Yeah.
Thank you.
Oh. Sorry.
I'm sorry, got a little late in coming in, but did you mention if any of this was Katz and Boss filmed, or was it all blown? Were you aware of?
So, I am not aware of the actual application or process of how they did it. It was, mulch stock that was taken off of just a general process kind of thing. So I'm assuming, that's why I wanted to look at the surface so I could at least kind of see that they're relatively similar kind of thing. And so, but I don't know the exact process. I'd have to kind of look into that a little bit.
They have cast film where you're at? They don't do that? It's
No.
all blown, okay. And then how does the brittleness that you notice, how do you feel like that's going to translate into recyclability? What's going to be the effect of that when it comes to, obviously, brittle plastic does degrade, but with your testing, where will recyclers see that in their process?
Boy, that's a good question. So you don't want to have anything brittle. As soon as it gets brittle, it's bad, because plastics are mainly tough. They want to have toughness involved in that kind of thing. So if you're looking at any secondary application that turns it into composites or any of that kind of stuff, you're going to want to keep it closer to its virgin form, that toughness, that high impact value. So anything that goes and makes it more brittle is definitely going to have an effect, and it's going to limit its use in there. Now, as far as what Kevin and what you're seeing in a pyrolysis unit, I don't know. I don't think you're going to see too much as far as that. And then as far as Quinn, that's what we're going to find out, but he can kind of talk about it a little bit more in his presentation, maybe, if he has any of that stuff. But yeah, you don't want it to go brittle. Oh, I can repeat it if you want me to repeat it.
I was just going to say, we know that plastic gets brittle as it's used, obviously, virgin versus, post-consumer plastic is always, post-consumer plastic in some way or another is always going to be more brittle. It'd be nice to correlate that brittleness compared to recycling when it's, at what point on that arc is it no longer good for recycling? Obviously the recyclability is going to go down as that arc goes up. So where do we, help recyclers to understand, hey, as long as we keep this arc, this position on the arc, because brittleness is always going to happen no matter what.
And when you look at it, the recycling aspect of this really dictates on where it's going. If it goes to Kevin and PDO or Bob or wherever it goes to and it's gasified, it's not going to be as big of an issue, I hope. But we may see it in asphalts. We may see it in Trex products or composite decking or that kind of thing. And so I think it really will be dictated upon its post application and how much, what the degree of it kind of thing. So, but no, those are good questions. So, thanks.
Well, that was a good setup for our next presenter. I'd like you all to welcome Dr. Zhang. He is an associate professor at California State University, Chico, and he's going to be talking about recycled polyethylene mulches for asphalt pavement applications.
All right, thank you, Lisa, and thank you, Zhang, for this great conference. And my name is Zhang. Right now, I'm an associate professor at California State University, Chico, and from the Department of Civil Engineering. So that's my background, and focus on the especially the pavement materials. Well, here for this topic, I see a lot of great presentation yesterday and today, and definitely Wednesday. So we know the problem for the PE mulch, it has a higher contaminant, right? So ideally, if we want to do the circular economy and recycle the plastic back to the plastic, that's the ideal case, right? Mechanical way or chemical way, advanced way. But if we have the high contamination level, can we find some other way to reuse it or repurpose it? So that's one of the applications I want to briefly talk about today, and give you some ideas of how we can recycle the plastic, especially here, focus on the mulch in the asphalt pavement. Every day we drive on that. So for the society, we rely on the transportation infrastructure. So how we can make it happen? So here's the outline of this presentation. So first, I'm going to briefly talk about the recycling of the solid waste in the asphalt materials. So we have the really long history to responsible and successful use solid waste in the asphalt pavement. So here I will give you two examples. One is a crumb rubber from the waste tire. So in our asphalt industry, we have more than 6-year experience to use the crumb rubber in the asphalt, and we have very successful use in California. And I will talk about that from the history perspective, and also talk about reuse or repurpose the plastic in the asphalt industry. So for the lab testing, field trial test, so we have 30-year plus experience. So we have some, the literature publications that, as well as the field pilot project to show the success, and hopefully that will be the future for the for the plastic recycling. And also I'm going to talk about a little bit on the ag plastic recycling, the challenge and also the opportunities. Especially I will focus on the recycling of the plastic mulch waste from the strawberry farmlands to the asphalt pavement. So thanks to the USDA, thanks to Lisa for the leadership, definitely the Karl for this project. So when we talk about from the strawberry farmland to the asphalt here, actually it involves the farmers, growers who grew the strawberry. So we pull out the mulch from the field. Karl and his team process the mulch, and actually that involves the plastic processing and recycling industry. So I see a lot of companies for the machinery, for the equipment, for the recycling, that part. And then we got the pallet. So after we have the pallet, so that's kind of involve the public works agency like the city, county, definitely the state DOTs, and also for the road contractors, the paving contractors, to make it happen. So for this recycling. And the good thing is, when we have the good pavement, actually that can reduce the transportation damage for the fruit or the berries. So there are some data. So if the transportation for the strawberry on the Rainbow Road, so it's caused like 6% damage for that due to the transportation. So that's a big waste, 6%. But if we have the smooth road for the transportation, for the fruit, the berries, so that's a good thing for the growers, for everyone. So that's a thing. Well, as I mentioned, so asphalt industry, we have a long history of the responsible and the success recycle or reuse different solid waste in pavement, including crumb rubber from the waste tire, steel slag from the steel industry, as well as reclaimed asphalt pavement. So that's a wrap, that's a distressed pavement. After 15 years, 20 years use for the pavement, so we have to mill it off, and that's become the reclaimed asphalt pavement, and we can put it back to the new pavement. right now in the US at a percentage of the 23%. Recycle the asphalt shingles from your house roof so we can process it and reuse it. That's a really high value material for us because in the asphalt shingles, it contains about 20% asphalt. So that is a high value material for asphalt industry. Definitely the waste carbon fibers and also the plastic. So first, I want to share this story about recycling the chrome rubber in the asphalt back to 1960s. So again, we have more than 6 year experience using the chrome rubber in the asphalt. So we start with chrome rubber for the low risk implementation for the pothole patching. So we fix the road using the asphalt rubber. Okay, so that's a starting point. And then after we have this asphalt rubber, so we use the asphalt rubber or rubber modified asphalt for the pavement preservation, the chip sealing application. So the idea for the pavement preservation, instead of we wait until the distressed pavement, we see the potholes, the cracking over there. So instead of rehabilitate, so every 5 years, so if we do some like maintenance, like you change your engine oil every like 3,000, 5,000 miles, right? So we can maintain the road in a good condition. So hopefully it can last more than 20 years, 30 years, or even 40 years. So we see some sense like that. So when we do the good maintenance for the road, for the preservation, so that is the one of the application is called the chip sealing. Definitely we have some other preservation technology, slurry seal, fog seal, etc. Okay. Well, in order to use the rubber in the mixture for the road, so we have specially designed the mix. So here, for the mix design, in the asphalt industry, we created the gap graded or open graded. The idea is we take a certain amount of the intermediate size of the aggregate to make the room to accommodate the rubber. We know the rubber takes the space. So in this way, so we can accommodate the rubber at the dosage of 15 to 18% by the weight of the asphalt. So we have this gap or open graded mix developed around 1980s. And then policies come, standards followed up, and also the DOT's specification on the asphalt rubber. Well, then we have more and more study and also the field implementations. Definitely will focus on the engineering performance and also the environmental impact when we use rubber, definitely the economic benefits using the rubber mix. And for the rubber mix, actually it can provide a longer service life compared to the conventional mix. So we have, so that is from the life cycle cost analysis point, so that is a very cost benefits. That's a kind of study around 2000, and then we have more and more study focused on the re-recycle the asphalt rubber mix, and also the more applications. If you look at the US map using the asphalt rubber in the US, is mainly focused on the southern states because the rubber improved the stiffness of the mix, so it's really good for the hot climate areas like the Texas, California. Well, if we look at the California practice, 2006, the Caltrans, California Department of Transportation, published the use guideline to use the asphalt rubber, and then the public resources or the legislation come and see like, okay, if look at that, so I think that's start around 2006. So let's say we have to put 20% mix that's containing the rubber in the state mix, and then ramp up to the 25% and the 35% recently by like 2020. Well, the Caltrans right now put about like 40% mix that contains the rubber for the state highway. So that is a politics driven, the process or the recycling. And then definitely the Cal Recycle, so they also have the rubber payment grant program, the city, county agencies, so they can apply for the grant to reimburse the cost difference between the rubber mix and the conventional mix. So that is a rubber. Come to the plastic recycling. So I mean the early start around like the 1990s. So there are some like patent work and also the field test. Some test section were really successful. Some testing was not. So that comes more and more lab testing around 2000. So there are two recycling methods of using the plastic in the asphalt. One is called wet mixing, one is called dry mixing. I will talk about these two technology when I talk about the result from this study. So we know the story, like 2018, China stopped the import of the waste plastic. So that's caused the chain of the reactions in the US. And actually in the asphalt industry, so we have some like reactions, responses, and we start from the literature review led by the National Asphalt Pavement Association, NAPA. So they have the really good report to do the literature review of using plastic in asphalt in the past 30 years. So what we have done in the past and what we can do in the future. And really quick, 2 years later, 2020, Caltrans built a pilot project for the Built 162 project using the plastic. So if you do the Google search plastic road in California, you can see the news, the story for that. Then 2021, Missouri Department of Transportation built the test sections using the plastic, followed by the Virginia DOT 2022 also construct the pilot project to see how we can use the plastic in the asphalt pavement. So for some like field data collection, and then we keep monitoring the performance. Again, when we use the solid waste in the asphalt pavement, we should use it in a responsible way, not just put everything in the pavement, right? So become the landfill. So we have to use it in a responsible way. So that's how we do. Well, also the National Center for Asphalt Technology, NCAT, they performed the NCHRP study to do the testing in the lab and evaluate the recycled plastic modified asphalt binder and mixtures and see how the performance to meet the standard. Well, looking forward, if we take the experience from the rubber, looking forward, so there will be like more specifications how we can use the plastic in the pavement, and legislation, that definitely some grant program, the policy-driven process to use more and more plastic recycled in the pavement. Well, the challenge to use the plastic in the pavement in the asphalt, so we know there are different types of the plastic. So they have the different melting point. If we look at there, when we have the low density polyethylene, the melting point is between 110 to 130 degrees Celsius. And the PP, that's around 160 degrees Celsius, and the PET, which is higher than 250 degrees Celsius. As a reference, so when we do the asphalt production, so the production temperature is between 130 to 180 degrees Celsius. So it's around like a 350 Fahrenheit, so when we produce the asphalt mix. Well, when we have some other like plastic, like the PVC, when it's warmed up, so it will emit the harmful gases to the human, so we prefer not to use the PVC in the asphalt road. Well, the challenge still now, the recycling rate is low. Well, we have the mechanical way, chemical way, biological way, and more advanced way to recycle the plastic, but overall, the recycling rate is less than 10% because of the cost. I hear the story yesterday, so even some raw material for the plastic is even lower than the recycled one. So that's one of the challenges to recycle the plastic. And for the ag plastic, based on the data, there are like 12.5 million tons used annually. So that's a big opportunity. We can do the recycling to different in the different ways, especially we can digest some in the asphalt pavement. Well, talking about the plastic mulch, the LDPE, so annually in the US, there are about like 450,000 metric tons in the US generated. Well, the good news is for the LDPE, the melting point is lower than the asphalt production. So when we blend the asphalt with the LDPE, so LDPE can be melted into the asphalt and used as a polymer. Okay? Can be used as a polymer. And however, it has a higher contamination level, 30% to 80% by weight. So in this project, we are going to answer this question. So how will this high contaminated LDPE, the mulch, affect the performance of the asphalt? Well, so we have two objectives of this work. The first one is to assess the influence of the PE mulch waste as well as its contaminant on the asphalt modification. So we will compare the modification effectiveness between the new PE mulch as well as the recycled PE mulch. And also assess the recycling strategy by using the dry and wet mixing method on the performance of the asphalt mixture with the PE mulch waste. So here is a close collaboration between the Washington State University. Karl, his team helped to process the pellets and then ship it to the California State University here. So we ran the blending in the lab using this heating mantle at the temperature 170 degrees Celsius, blended the pellets with the asphalt and produced the plastic modified asphalt and used in the lab. Well, a little bit background on the asphalt pavement. So everyone drive on it, but a few really think about so what's going on there, right? So here I just one slide briefly talk about the asphalt 101 class. So more than 90% of the road are the asphalt pavement, or we call it the flexible pavement, and the rest 10% that is concrete, okay, concrete pavement. Well, for the asphalt mixtures, roughly, if you look at close here, so for the asphalt mixture, in it, we have about 95% by weight, that is aggregate. Big rock, small rock, so they form the skeleton of the mixture and put roughly 5% asphalt binder to bond the aggregate together, okay? And then we have some like a performance enhancers. We use a polymer in it, SBS, SBR, definitely the plastic is a polymer, so we can use it as a polymer modified asphalt to improve the performance. We add the fibers to improve the ductility of the mixture and reduce the cracking. So we use the anti-stripping agents that can reduce the moisture damage, and we use the warm mix additive to reduce the production temperature and reduce the fuel use. That's a warm mix additive, and also we use the antioxidant additive in asphalt to retard the aging of the asphalt. So that can extend the service life of the asphalt pavement. So we use a lot of things in asphalt, not only the aggregate and the asphalt binder. So we use the additives. So that gives the opportunity so we can use a plastic as a polymer to modify the asphalt and improve the performance. Well, there are two typical distresses in the road. One, we call it rotting. That is a high temperature related problem, especially in the south part of the US, like Texas, hot climate area. So rotting is a typical distresses. If you think about the asphalt like the honey, so when you warm it up, so it becomes soft. So that is a rotting problem, high temperature related. Well, the second problem is cracking. It's a load related and also the low temperature related. Like if you travel to Alaska, you will see a lot of transverse cracking over there. So that's two big problems for when we design the asphalt mixture for the asphalt pavement, rotting and cracking. One is high temperature, one is low temperature related. Well, when we select the binder, so in this way we have to use appropriate asphalt binder in different climatic zones or climatic regions in the US. So you can think about the binder used in Texas would be different than the binder used in Alaska, even in California, so we use a different type of the binder. So how can we select or how can we use appropriate asphalt binder in different climatic zones? So here we use the performance grid system. We call it the PG system. For example, the binder used in Chico, California, so we use a PG 64 -10. So PG stands for the performance grid. The first number 64 means this type of binder can be used in the area where in the summertime, the pavement temperature can be as high as 64 degrees Celsius. That's the first number, 64. -10, that is the lower temperature in the wintertime. For the pavement temperature can be as low as -10 degrees Celsius. So one is high temperature, high pavement temperature. The other one is a low pavement temperature. If you look at the PG map, the performance grid of the binder used in California, so the South Coast, Central Coast, and the Inland Valley, Sacramento Valley, so we use a PG 64 -10. Caltrans recommend to use PG 64 -16 in the North Coast, Low Mountain, and the South Mountain area. So you can imagine, or that area, winter is a little bit colder, right? High mountain area has desert area, the performance grade is a PG64 negative 28, and in the desert area, it's bumped the high performance grade, the PG70. You can expect the summertime over there, PG70 negative 10. So that is the PG map in California. And then come to the polymer or the plastic modified asphalt binder. So we start with the PG64 binder modified by different percentage of the PE mulch. We use a new PE mulch as a control one. So we start low percentage, 0.5%, 1%, 3%, 5%, all the way to the 15%, and we figure out 3 and 5% are the appropriate amount of the binder, appropriate amount of the plastic to modify the asphalt, 3% and 5%, and then we come to the recycled PE, the mulch. So we have the effective PE content, which are around like 70%, again at 3% and 5%. If you look at there, when we have the PG64 binder, so it can be only used in the inland valley and also the north coast region, the PG, this green and yellow one. But if we add 3% or 5% plastic there, the PE, LDPE over there, so actually we can extend the use of this binder to the desert area, to the PG70 area. Same thing for the recycled one, for the 5% recycled one, so we can extend the use of the binder in the desert area. So that's, and another conclusion from this study, when we have the recycled PE mulch, it has a lower modification effectiveness than the new PE mulch, mainly due to the lower PE content. Well, climate change, that's a big issue now. Well, we know from there PE mulch can increase the stiffness of the binder, help to increase the high performance grade and benefit the rotting resistance. Well, as a climate, kind of like a temperature increase or more frequent heat wave, if you live in California this year, especially the inland valley is tough. I put a heat wave over there, like in Chico, we have a few days about 115 and even 120 Fahrenheit this summer. So when we have this high temperature, the rotting becomes the issue. Well, when we use a plastic modified binder, it can help mitigate this problem. Okay? So actually, when we use a plastic, that can help to improve the resilience of the pavement due to the climate change. And actually, the University of California, Davis, so they work on the study and actually give the recommendation to the Caltrans for the Central Valley area, Inland Valley area, instead of using the PG64 negative 10, actually, due to the climate change, so it's recommended to use a PG70 negative 10 binder in the Inland Valley area, this yellow area. So that's comes, if we have the still PG64 binder, we cannot use it, but when we have the plastic modified 3%, 5%, and even we have a lower grade like a PG58 binder at 5% effective new PE, so we can use this type of binder to deal with the climate change issues in the future. Talking about the performance of the asphalt mixtures, we collect the PE mulch waste from the Washington side and the Nebraska side. So we have the RPE-Washington and RPE-Nebraska last year, and it has a different effective PE content. And we collect the control mix. We use a recycled wrap mix, the control mix from the field, and also we designed the mix without the recycled, without the reclaimed asphalt pavement, without the wrap. So that's a 2 control mix we use. And then we come up these 2 recycling methods. One is called white mixing method. So we use a PE mulch as a binder modifier. So we first blend the PE mulch with a binder. So we create the mulch modified binder. Because it's mulch modified, it has a higher stiffness, higher strength, so we have to increase the production temperature. So we mix the aggregate with a mulch modified binder at the temperature 175, and we have 3 mixes. So here's the W over there that stands for the wet mixing method. Well, for the dry mixing method, so we blend the PE mulch as a mixture additive. So we first blend the PE, the pellets with the aggregate and then blend with an unmodified binder. So during this process, the mulch can be partially melt into the binder, okay? But it's hard to know what the percentage of the melting into the binder in the dry mixing. But in this way, so we use a PE mulch as a mixture additive. So we create 5 different mixes, and we use a 3% plastic, and also we even use a 6% plastic in the dry mixing. And then, as I mentioned, 2 big issues for the asphalt pavement, rotting and cracking. So we do the cracking resistance test using the ideal CT, rotting resistance following the standard, and run the Hamburg test for the rotting resistance. And also, we also do the drain down test to determine the production uniformity when we add the plastic into the asphalt. So cracking resistance, if you look at the control mix with a recycled material with a wrap, so it has a ideal CT around like 32, which is less than 50, so that's a really brittle material used currently. Well, when we have the control mix without the wrap, so we have the 170 CT index, so that's a really good number. So yeah, the 50 is a limit, so we have much higher than the 50. So, well, when we use the plastic over there for the wet mixing, so it's kind of like a decrease to the 103, 104, but still it's much more than 50, the threshold, the value, so which is good. And for the dry mixing, it's 140, 148 on average. So it has a good cracking resistance. So we have some cracking, the ranking over there, and the conclusion is the dry mixing method is a preferred way to include the PE mulch waste in the asphalt. And also it allows a higher percentage at 6%. And this is also the preferred way for the paving contractor to include the additives into the mix, the dry mixing method. Well, the rotting resistance, there's no issue for all mixes. The rot depth is much less than the 12.5 millimeter at 25,000 wheel passes. Well, for the racking, definitely the 25% rack mix has a lower rot depth, well followed by the 3% RPE from the Washington using the dry mixing method. But in general, there's no rotting issue when we add the plastic into the mix. And for the drain down test, again, when we add the pellet mulch using the dry mixing method, so it reduces the drain down, and actually that's improved the production uniformity. Well, the next question is how much PE mulch or the PE waste so we can be recycled into the road. The engineering answer is it depends. Depends on like for example 1 acre farmland. I don't know that much of the the farm and how large 1 acre, so I just do some like a search. What is like a 1 football field is about 1.3 acres, so that's kind of size, can produce 10,000 pounds of strawberry. Please correct me if I'm wrong for this number. Well, in Florida, they use about 220 pounds in 1 acre, and in California, it's kind of more dense, right, using 450 pounds new mulch. And then when we collect it, so here we assume like 30% contamination after the processing. That's we can see the data from the Karl's presentation. So then we can collect around 300 pounds recycled PE mulch in Florida and 640 pounds from California. And if we do the mass, the dry or the wet mixing at 3% by weight of the binder, when we do the 1 ton of the mix, so we can incorporate 3 pounds of the recycled PE pellets. Well, when we build 1 mile of the road with a thickness of 2 inches, well, roughly we have to use 820 tons of the mix and reuse around 2,500 pounds. It's a little bit over 1 ton of the RPE in this 1 mile of the road. So we use reuse the mulch. It's roughly equivalent like 8 anchors collected from the strawberry field in the Florida, or 4 anchors from the California. So I have 1 minute left. So as a faculty or the lecturer in the university, we always give the homework to the student, to the audience. So how about at 6% when we use the dry mix method? So how much PE mulch waste can be recycled into the road? So that's the homework for you back to the home. With that, thank you so much. Thanks the USDA for the grant, and also any questions. And here's the answer.
Question here.
Hi, I'm Sam from the Toro Company. How does the use of the plastic mulch affect the heat holding capacity of the asphalt, and how does that contribute to like localized heat effects such as like urban heat island effect and so forth?
That's a good point. For the urban heat island, so I don't think that's much difference. So because it's asphalt pavement is black and the mulch is black, so color-wise there's not that much difference. I don't think it will affect the urban heat island, the issues. Is that answer your question? And also, roughly, so we put the 3% by weight of the binder, and the binder is a 5% by weight of the mix. So roughly we put like a 0.15% by the total mix. So it's a small amount, but that makes some the impact for the performance, but not that much. Yeah.
So it's kind of a three-part question, and I've spent most of my life in winter climates. So have any tests on the asphalt been done on how it holds up under magnesium chloride applications, or if the roads are salted, and what effects studded tires might have on the asphalt in terms of the lifespan?
Sorry, can you repeat the last part, like the tire, you see?
So magnesium chloride is usually used when they're expecting ice or frost, and so they'll spray the roads while they're dry, and hopefully it'll prevent the ice from building up. And salt is used to melt ice. Sorry, I recognize you're in California, and you probably don't have a lot of experience with that. And then people that don't have SUV vehicles will often switch over to studded tires, where they'll have little metal studs in them.
Yeah.
And so I'm wondering how the asphalt holds up under all three of those.
Okay, yeah, I used to live in Pullman, Washington, so we use a star tire. So that's create significant damage to the road. And probably, I think probably you want to ask the leaching issues for the materials, right? So from the asphalt pavement, especially when we use a rubber, so that's a big issue. Sometimes if it's close to the river, so there might some leachings, but for the plastic, it's ongoing study, so we'll work on that. But definitely the started tire creates a lot of damage to the asphalt pavement, yeah. Yeah, and the WashDOT, so they have to pay billions of dollars to fix the wearing from the started tire, yeah.
Have you looked at how the asphalt might hold up differently with the plastic mulch in it in those winter conditions where they use magnesium chloride and salt on the roads? Or is there no difference?
There not much different for the chloride to corrosion the asphalt, but definitely for the steel, that's a big issue for the concrete pavement. So they put the rebar over there, so that is the corrosion for the steel, for the concrete, but not for the asphalt. It's a kind of limited impact using the salt in the wintertime. Yeah.
Okay, thank you.
Yeah.
Can you please talk about microplastics in the environment as a result of rubber meeting the modified asphalt?
Yeah, that's a big issue for the microplastic. So, yeah, I haven't really for this study I haven't really looked into that. So, like, the wearing or whatever to cause the leaching of the microplastic to the environmental. But there are some studies from the Australian. So they run the test in the lab and evaluate so how the asphalt can hold the plastic, hold the rubber, different materials, and also the leaching. So if you can send me the email, so I will send you the report from the Australian study, so you can see their experience. Yeah.
Hang on, yeah.
Yeah, but the microplastic not from this project. Thank you. Yeah.
Have you done any analysis like what the upside is? Like yeah, how much, let's say this is a hit and we start doing it, what is the potential for sequestering mulch, in California or across the country?
So how much we can recycle?
Well, meaning like I have no idea how many miles of roads we build every year. Like what? Like it would be great. It would be great if this was an outlet for it. But if we can only take 100 tons a year, that's probably focus our efforts elsewhere.
Okay, yeah, I see the point. So, well, the data for California. So, Caltrans own, the state road about 50,000 miles. Lane miles, 50,000 lane miles, but definitely each year they won't, rebuild all this road. Yeah, but that's an opportunity, but that's only for the state road, but also we have the opportunity for the city and county roads. So there are a lot of road, all the huge markets, so we can digest some of the PE mulch into this application, but not all of this, yeah.
Sure. Great. Well, thanks, Quinn. Yeah. And I was told Melissa's got a pretty short presentation, so it was nice to hear the asphalt discussion continue on. But that was a great presentation. The first time I've been to a conference and had a homework assignment. So I think Jean will be collecting those at the end of the conference. But it's my pleasure to introduce now Dr. Melissa Kono. She's an associate professor at the University of Wisconsin-Madison. So Melissa will be presenting on incorporating ag plastic recycling into municipal recycling programs, a case study.
Thank you, Lisa. No pressure at all to be the last one, and I'm not sure if I'm supposed to give you like a rousing send-off, or we have a joke in my office because I am always the speaker right before lunch, and my colleagues said I should just start including an invocation for the lunch in every one of my programs, but maybe Jean is gonna be doing that. So thank you to Jean. I love this conference. It is my favorite to attend every couple years. I wish it was more often. And I'm just so honored to be here. And this is my desperate attempt to add anything of value to this conference, because I'm not sure what else to include at this point. But had I known we could change the title of our presentations, Dr. Englund, I perhaps would have done that. Because this is the abstract that I submitted. The things I will promise to come to California. But I'm actually going to cover a couple different studies, and my goal here is to maybe give you some ideas for recycling events or collaborations with partners, or ideas for others as well. So I tried to include information in my slides, because I know we have access to the slides after the conference. Also, I have a local government bent to my work. Maybe that's what I'll add here, because when I'm not working on agricultural plastics recycling events, I mostly do election training. I train election workers. In fact, it was election day in Wisconsin on Tuesday, so I'm the clerk for my local municipality. We call it a township. That's the rural incorporated area. So I ran the election and then drove to the airport at 3 o'clock in the morning in order to get here. So I had to kind of balance my two loves in one day. I told this joke at the last conference, but it's an election year, so it might be a little bit funnier or more relevant. But do you know what politics and ag plastics have in common? They're both dirty. Except for this particular sheet of plastic, which this is my actual child. He's not an actor, and he's at a birthday party of the son of a dairy farmer, and we reuse our egg plastic for lots of different things. I use it in my landscaping at home, and we apparently use it instead of like having a bounce house. And I know Dr. Englund said that, I won't chide you after this one, but that all plastic is dirty, but I will tell you, you could eat off of this sheet of plastic because it literally has an entire bottle of Dawn dish soap on it, because when you put soap on it, it sends those kids shooting down that hill, and it's lots of fun. So So when I'm not ensuring the continuation of democracy, one of the things that I do is organize recycling events on a small scale, and I'm working now towards more statewide projects. So I do partner with plastic companies. I am very fortunate where I live that I have companies that are willing to take the plastic within some guidelines, of course. Also, one of the companies I work with, Revolution Plastics, does provide on-farm collection, which is very convenient because in Wisconsin we have a lot of dairy farmers, and it's just more convenient for them to be able to recycle on the farm, and then it's a regular pickup schedule, and that comes at no cost to the farmer. I also organize events for farmers to bring recycling. Of course, they would rather have our on-farm collection, but for smaller producers, it makes more sense to bring it to an event. And then the companies I work with process the plastic within the United States and make it into products. So I wanted to include some information about, and I'm sure that this is similar to other parts of the country too, but some information about the different types of recycling programs we operate and how I've tried to incorporate agricultural plastics recycling into them. So one of the things that Wisconsin has that I'm sure is similar to other states is that it does require every municipality to operate a recycling program, and it also bans many recyclable items from being in landfills, the things that we would typically expect. Plastic bottles, aluminum containers. However, there is no landfilling ban on agricultural plastics in Wisconsin, and obviously a policy like that would go a long ways towards moving away from burning the plastics, which is very common, and also landfilling plastics when we could recycle them. So we have, so because we are required to recycle, many of these products, we're given a small grant, but it's really what it is an unfunded mandate, because the grant that I received from my municipality from the Department of Natural Resources is $113 per year. And the economist in me thinks the amount of time I spend putting together their grant application and their annual report far exceeds even my staff costs to do that part of it, let alone it costs about 20 times that to run my municipal recycling place, which is only open for 2.5 hours every Saturday. So one of the other programs that we have is through the Department of Ag Trade and Consumer Protection. This is our Clean Sweep program that takes hazardous household, agriculture, and prescription medications. These are very popular events, but they're very expensive to operate. I have one coming up in a few weeks. It will cost me probably close to $30,000 in just disposal costs for all of these. I do receive a grant from the Department of, I'll call it DATCAP if that's okay. I receive a grant, and that covers only the collection of the waste, the household waste and the agriculture waste. Now, this program started as an agricultural focused recycling event, but I was just meeting with the organizer, which I'll talk about next, and he said most of the waste that's collected at these events is household, very little of it is agriculture. Now, the good news is that it's because agricultural producers and vendors have really streamlined their processes, so there is less waste, chemical waste, but also we do really want to keep a focus on keeping those hazardous materials out of our environment. At my event, as well as other Clean Sweep events too, we collect other materials such as tires, batteries, appliances. I just received a grant to cover the electronics. So, it's very popular, and we know that events like this, when people can bring a lot of different types of items, tend to increase participation. So the other thing I wanted to talk about is some interagency collaboration that I've done between the Wisconsin Department of Natural Resources and DATCAP, because what I realized in working with collectors and recyclers is that they don't work with local government or government as much as I do in my daily job, and they were finding it very frustrating to try to kind of crack into that area or just not maybe understanding. And it's also not their fault because there is a mismatch here. And as you can see, the Department of Natural Resources administers the recycling programs and grants, whereas the DATCAP agency, which is completely separate, operates the Clean Sweep program. And can't you see just like kind of a natural crossover there? But yet they're very separate. They're both regulatory. They both have programs that support farmers, but they're different, very different types of programs. And so what was happening too is that they were also fielding calls from farmers about how to recycle their agricultural plastics. And also sometimes when farmers were frustrated with either a lack of opportunity to recycle plastic or maybe we're not adhering to program rules and we're not getting the recycling picked up, they would call these agencies. And these agencies were viewing any type of contact from a farmer as a complaint. And I would also kind of question how you complain about a no-cost program, but I just kind of needed to get these agencies on board. So I have been working with them the last few months to kind of streamline some of the grant programs that they offer and how we can incorporate agricultural plastics recycling into the already existing programs. And it is even something as simple as they have a page for their DATCAP grant for the Clean Sweep, and I said, would you be willing to include information on recycling agricultural plastics? And they're like, well, we can't do it if there's no money. And I said, but I have it at no cost right now. Do you think you can put it on your page? I mean, it's just like simple things like that. And so the reason I wanted to include this is because I know how frustrating it can be to try to navigate the nuances of government. In fact, a greenhouse had contacted one agency who then looped me in and the other agency, and that greenhouse finally said, I can't keep up with this government bureaucracy on this email chain. I don't even know who I'm talking to anymore. Fair enough. And so I just think that we could perhaps streamline processes a little bit better. Here's an example of an event that I had in 2019. This was a DATCAP grant for agricultural products only. I did not take any household products at this event due to the way the grant was structured. There was a household program later in the year. But I wanted to do a little bit of a trial to see if we took only the agricultural chemical waste and incorporated egg plastics, what turnout would be like. So I targeted promotion to farms on our mailing list, as well as a lot of outreach to the local agricultural businesses who are selling the products to farmers and hopefully encouraging them. And these businesses can also participate in this event as well. So if they had any extra inventory, they were welcome to bring it at a low cost. I did offer recapture bags ahead of time because this event was really focused more on small producers who wouldn't qualify for on-farm collection. And even though I offered the recapture bags, which would have made my life a lot easier, no one really took me up on it. And they would bring their plastic in hay wagons and horse trailers, which required a lot of manual unloading of that plastic. I didn't collect any other materials at that event, but it would have been maybe a good idea to include tires, especially tractor tires. The next event that I have in a couple weeks is incorporating agricultural plastics with my Clean Sweep event. I'll be collecting a lot of other materials at that event as well. But in order to market to farmers and other businesses so that we could collect more plastic, I did a direct mailing, and I was really intentional about the timing of this. I did it in the spring because the plastic has a slightly seasonal usage to it in Wisconsin, whereas yes, dairy farmers will use like silage plastic in particular year round. They tend to have more of it towards the end of winter, and I didn't want them to dispose of it improperly before they could bring it to my event. So I sent out a save the date. We do have a mailing list, and that actually includes almost every farm in the area. And so we mailed out postcards, and then we also included it in our newsletter. And then in addition, I did a direct mailing similar to this postcard where I had a greenhouse theme, and I wanted them to save their greenhouse plastic because about 60% of my community is Amish and Mennonite with a huge focus on greenhouses. And as you know, that's a bit more of a desirable plastic, and they do tend to reuse it for several years, more so than we might see with other types of egg plastic, but I wanted them to have an opportunity to recycle it when they knew there was an event coming up. I also was intentional about where I'm offering these events, knowing that it's harder for them to transport the plastic to them. So I have 2 events throughout the county. And then I've also been doing targeted advertising on Facebook, which I really enjoy because I can fix the audience and I can track the analytics, and I can see who is sharing and who's clicking on it, and just knowing that that message is getting out there. Just a couple tips. I think I've actually shared most of these at a previous conference, but I know we have some new people here, so I just wanted to include a couple things that I have found that are useful at events. One is recapture bags or some other type of way to kind of streamline that collection has been really helpful. Also heavily promoting. I would also add emphasizing that it is a one-time event, if that's what it is. People are less likely to participate if they think that they can do it at any time, and this just kind of goes to the psychology of recycling. One, if it's an extra step, participation tends to drop off, but if they think that they have any time to do it, they're less likely to do it if it's like a more concentrated one-time event. It is helpful, I think, to couple with other events, and what also that speaks to is having an opportunity to get hazardous material out of our community and into the proper hands of those who can properly dispose of it. Having collection events is ideal for smaller places who can't have on-farm service, but it's also helpful to have extra staff like a skid steer and a loader and baler if possible. This event that I have a picture of here was actually, I had a lot of marinas participate just because of where it was located in the state. And that, I really liked having marina participation. One, the plastic is pretty clean, and 2, they have a staff person who didn't blink an eye at having to bale this, they didn't bale it, but gather it up, make sure it was properly prepared, cutting the grommets off, etc., and bringing it to the event, where sometimes I have farmers grumble a bit about having to make an effort for that. What I really am hoping to do too is finding more sources for plastic and some strong partners when it comes to recycling plastic. Some of my goals, ongoing goals and things I'd like to do is, I have a very solid market locally for silage plastic and greenhouse film. I really struggle with the bale wrap because that is a popular product that is used where I'm at, and I don't have an outlet for it, although being here at this conference has given me hope that when I see it is being recycled other places, and I'd like to help expand that market. What also has given me hope is some changes in policies. It is not uncommon for plastic to be burned in Wisconsin. It is illegal, but it's not enforced because it's very costly to enforce it. But I would love to see some policies. And when I, heard the Clean Farms presentation yesterday and some of the other presentations, having strong policies about recycling, I think, would go a long way. I'm hopeful we can have that in Wisconsin. I'm not sure we're there quite yet. The other thing I would like to do is increase the partnership and the capacity of plastics companies that manufacture all types of different products throughout the state, and how they might be able to incorporate at least some egg plastic in their products. For example, that Marina project, they actually have a local plastics company who will take the plastic at a very small cost. And what's also nice is there's a sustainability and a sea grant to help cover that small cost to actually take that plastic to a company locally, so there's a small carbon footprint, and be able to have it made into new products, and I'd like to work with some companies. Right now I have an intern who's working on some of those connections, and he's also working on creating an ag plastics and products recycling directory that can be used both on the DATCAP and DNR site as well as our extension site, so that when people are trying to find proper places for their agricultural products and plastics, that they know where to go, while at the same time expanding those opportunities locally. So finally, I hope you reach out to me if you have any ideas for me, but also if I can help connect you to people in Wisconsin. That's really what I do, is to make those connections. So I've included my email here, and with that, I'll turn it over.
Thank you, Melissa. You bring up a really good point, and I value your presentation, because from an inclusion perspective and equity, we struggle even in some of the work that we've been doing. And we've partnered up, and as you heard in the presentation from the collaborators, with the practices of mechanical collection. But if we take a closer look at that, I mean, for a very small scale grower, let's say something 5 acres or less, that practice is not as accessible for them.
Yes.
Ben has mentioned, there's ultra binders, and that is also, some growers do use that, but when we're talking about a grower that has maybe 1 acre or half an acre, it's hard to do that. If we look at it from the perspective of drip tape, Tate just left, but I don't know if Sam has other ideas. It also, we struggle with that because, again, that densification is so key. We started a program in Monterey in collaboration with Regen and Flipping Iron to sort of make the drip tape recycling efforts accessible for the small scale growers. And even there, we're starting to get more feedback where they're saying, hey, the densification is so important, if we could get that to happen. So my question to you is, how do you work around that? I know you mentioned in there that you guys sometimes have a baler on site, but how do you make that process more accessible to these smaller growers, or sometimes some of the practices that are accessible to larger growers, isn't an option for them?
Yeah, I mean, it's a challenge. We have encouraged small producers also to kind of co-op, and so maybe they'll share, there'll be a dumpster on one farm. This particularly helpful with greenhouses too, where neighbors can kind of share, because they wouldn't otherwise individually qualify for on-farm collection. And maybe, like, I had somebody bring plastic in a horse trailer, and I said, well, how long did it take you to collect this? And he's like, several years. So it's just not feasible that he's going to come, he's going to have enough plastic even on an annual basis. So we've suggested doing co-ops with neighbors. I do like these small events if they're local enough, so that people, it's nothing to maybe have a recapture bag. I can't say enough about recapture bags, because they keep it all there, and you can just pull it off the back of the truck. They hold about 200 pounds. It's easy enough to just pull it off, no matter how strong you are. So, I mean, it's not a perfect solution, but there's a couple ways to kind of cobble it together.
And then I have another follow-up. Dave and I were talking, and one of the things that we've seen, especially for some of the very small scale farmers, are sometimes they rely more on reuse systems. We've seen some growers in Oxnard that use like deer fencing instead of mulch. Dave was mentioning the reusable, what did you call them? The row covers. Have you seen other systems in these very small scale farms where they have like reusable systems in place?
Well, I mean, like in my community, I mentioned the Amish and Mennonite make up a significant percentage of the population, and they are very thrifty when it comes to reusing things. They will say to me, well, why would I recycle it? I'm going to use it next year. And it's like, well, you've used that plastic it's like falling apart. I'm not sure I can recycle it at this point anyway, but I don't, and that it does kind of speak to my lack of markets for things, that I really only have a outlet right now for a few things. Of course, I'd love to expand. Netting would be another one. There's nothing I can do. And then again, the policies where I'm at is that it can be landfilled. So, I mean, it's almost like a cop-out to say, well, I can't take it, so you can just put it in the garbage, and they usually do. I did not want to end on that note, so somebody give me...
No, I'm on the contrary, thank you, because I know that this is a topic that at this conference we tend to focus on large operations, so I appreciate your work on smaller operations. Thank you.
Yeah.
Yeah, thank you, Dada here from Washington State University. Great listening to Karl and Co. and also Melissa for your good presentation. So quick question, what is the greatest challenge you've witnessed, or maybe if you haven't practiced in that area, what is the greatest challenge you think can be witnessed when incorporating used mulch films into municipal solid waste collection systems?
Yeah, I feel like I'm in a job interview. I will say it is navigating the relationships of the stakeholders effectively so that I still have a good relationship with them and they're willing to continue down this road of recycling. So whether it's encouraging farmers to continue to recycle even when they deem it as inconvenient or they don't have time, while also making sure that they follow the rules so that I can preserve the opportunity that we have for collection. Because if it's not profitable for those collectors and recyclers, why? They're not going to do it, right? They're business people. And sometimes farmers don't necessarily understand that part. They say, well, I want them to come pick it up from my farm. And it's like, well, don't you understand that might not be the best business decision for that recycler. And it's kind of still playing that space in between those two so that we can continue on this goal of recycling agricultural plastics as much as possible.
Melissa, great presentation. Also, great job to everyone else up there as well. I am a social scientist, so I'm curious if you can tell me a little bit about how the growers that you work with who come to your collection events react to them. Are they excited to be able to recycle? Are they mostly grateful that it's free? Or can you tell me just a little bit more?
Yeah, so I did this presentation at a conference, and I can send it to you because it is the only 15 minutes of qualitative research that is usually involved here. But I did a survey of those participating, and the only negative feedback I got was from those who were on a waiting list, and it was like they thought they had this like right to like liberty and egg plastics dumpsters. And it was like, they would say in the responses, I am angry, I want a dumpster and I want it now. But also they wanted to participate, which I found very encouraging. And it's usually, complaints are few and far between, but I felt like working with those agencies, that was kind of getting blown up, because if they're getting 1 or 2 emails a year, that's not really demonstrating how happy everybody else is, right? When we're talking about 2,000 other people who are participating. Leah.
I just wanted to give a quick example. I live in Minnesota, and I've been working with the University of Minnesota Extension Program when they've been doing the recertification for all the professional applicators.
Yeah, I'm hoping you'll come help us. I was talking to Mark last night.
I was going to say that to come because Jolene Warnke, she leads an amazing recertification program, and I've been participating to promote the Ag Container Recycling Council, but to show the applicators how to properly triple rinse their containers, but at the same time promote our program. And, icing on the cake if they're gonna participate in our program, but if they don't, at least they will properly dispose of their containers properly. But hopefully we'll be able to see a pickup in the numbers in Minnesota. But, but Jolene and I have been talking about to implement more clean sweep programs. So almost kind of like integrating what you're doing in Wisconsin and then what we're doing in Minnesota. So I think we all three need to talk and kind of bring that all together. So,
and I don't live far from the border, so
Perfect.
They allow me to cross it at this
Yeah.
point.
Well, we've had Iowa State, North Dakota all
Yeah.
come up, so, you know, everyone's welcome.
Yeah, anytime.
Yeah.
Gene?
All right, well, if that kind of wraps up the panel, great panel. Just as a reminder, I will be sending out the proceedings to everybody probably later on this afternoon. We've got it pretty much close wrapped up, so hopefully I'll get that out to everybody. You'll get the recordings, all the presentations, the list of attendees. I've already sent the VIP list out. So have a safe trip home, and cheers. I can drink beer now. Be on the lookout